Introduction to VMware vSphere 5.5. So what problem does virtualization solve? Well, the problem virtualization solves is the wasted resources and the high overhead of physically deployed server workloads. First of all, a server workload is a combination of one or more applications installed on an OS. I can install that workload physically, and what that means is installing the OS and application onto a dedicated physical PC server. Now, in a lot of cases, I have local captive disk, and I uplink the PC server to one or more LAN segments, and users access the application, interact with the OS through the LAN segment. The problem with physically deployed PC server workloads is every time I have a new workload, a new application and OS combination, I have to buy a PC server, and before I know it, I've bought dozens or even hundreds of PC servers. My costs are through the roof, my overhead's through the roof, and so on and so on. This is the problem that virtualization solves. Virtualization says, first of all, I don't need as many PC servers. Maybe I can get away with just 2 or 3. Depends on the size of my company. I don't want local captive storage. I want shared SAN storage. I want to be able to consolidate my investments in storage into a central storage appliance, provide the bandwidth, the capacity, the performance, the scalability, the reliability, redundancy, backup and recovery, and so on that SANs provide. I don't buy entry-level machines. I buy higher-end PC servers with high-end CPUs, high-end memory, which means lots of memory. And then here's what I do. I install VMware's vSphere software on my PC servers. This would be ESXi, vCenter, enable all the features and so on. And then when it comes time to deploy new workloads, I deploy the app of my choice, the application of my choice, just like on the left. I deploy the OS the application requires, but I build it on top of virtual hardware, not physical hardware. So this whole thing, the application of my choice on the OS of my choice on virtual hardware, is called a virtual machine. Now, virtual machines are 100% software objects. They are a task to ESXi, which is VMware's hypervisor for running VMs, just like normal applications and programs are tasks to Windows or Linux. So what ESXi does is it simply runs one or more VMs, either if it has the resources in parallel or by task switching from one to the next to the next to the next. Now, what makes this work is the virtual hardware layer. All my VMs have a virtual hardware layer. The virtual hardware layer is software that looks, acts, and functions exactly like physical hardware. It is indistinguishable to the OS. So it's a software abstraction, software that acts like hardware. It creates virtual hardware. And when the guest OS does IOs to the virtual hardware, those IOs are actually redirected to the backing physical hardware, and they might, for example, result in storage IOs on one of my storage volumes on my SAN. So it maps the virtual hardware IOs to physical hardware IOs. Now, what makes this especially useful is the fact that virtualization is completely transparent to the guest OS and applications inside a virtual machine. Now, let's talk about the major features that are included in VMware's vSphere. Now, at this point, I'm going to talk about features that are available on many different license tiers. We're not going to focus on features for specific license tiers yet. This is just what vSphere as a whole can do. First of all, the foundation of VMware's virtualization platform is a hypervisor called ESXi. A hypervisor is an operating system whose job is to run virtual machines, nothing more. So this provides true enterprise-class server virtualization capability. Now I have a machine, I can run VMs on it. Next, I want to centrally manage all my ESXi hosts. I want central management, I want performance analysis, I want monitoring, and I want access to all those high-end license features that my company paid for when they bought their vSphere licenses. The tool for that is vCenter Server. vCenter Server comes in two forms. vCenter Server can run as a service on top of Windows. That would be Windows Server 2008, Windows Server 2012. Or I can actually get a virtual machine that is a vCenter Server virtual machine. It's called the vCenter Server appliance. I import it. We'll show you how. I boot it up, I configure it, I put it into service, and I use it as the central management console for all of my virtualization software, hardware, and so on. Now, one of the first problems that VMware solved with virtualization is resource balancing or resource management. The first way they solved that problem is I can right-size VMs to exactly what I need, so I don't have to dedicate a whole server. But the thing that put VMware on the map was vMotion. vMotion is their name for live VM migration. That is moving a VM from one host to the next with no perceived interruption in service, no risk to guest OS application failures or guest OS failures themselves, and no VM downtime. vMotion was truly unique when it first came out. Then VMware moved to the next step, and what they did is they invented load balance clusters. Load balance clusters are clusters that you create of 2 or more ESXi hosts that essentially run vMotion on autopilot. So the cluster monitors server load, monitors VM resource demands. If a VM is resource starved or potentially becoming resource starved, DRS will go look at the other available hosts. If any of the hosts has the resources, CPU or memory that the VM needs, DRS can either recommend or actually move VMs to the new host. If you let it move the VMs to the new host, it means that it fixes resource contention problems before they even become a problem. Now that's great for CPU and memory. VMware also has a solution for storage resource balancing. They have, first of all, storage vMotion. Storage vMotion solves this problem. I have a VM. Its virtual disk lives as a file on a backing data store somewhere, either local storage or preferably shared storage. The problem is if the volume that the VM lives on is full or nearly full, I might have a VM outage if I need to grow my VM's virtual disk and there's no space left on the backing data store. Storage vMotion lets me pick up a VM's virtual disk and all of its other constituent files and migrate them to a new data store while the VM is hot, in service, and doing IOs. And it can do this with no downtime, no guest OS dependencies, no application dependencies, and so on. So I can rebalance my storage use for either capacity or bandwidth on the fly. Now, VMware then automated that capability through storage DRS. Just like regular DRS load balances CPU and memory automatically, storage DRS load balances storage capacity and IO bandwidth automatically once you make storage clusters. Storage clusters are a topic for a future class. The other thing VMware makes is a feature called storage profiles. Storage has different characteristics. So for example, I could have relatively inexpensive storage based on very high density disks, usually SATA drives, organized into a RAID array on my shared storage appliance. That data store would have lots of capacity, but not necessarily the best performance. I could have other data stores backed by either solid-state drives or high-end enterprise serial attached SCSI drives. Those data stores are much, much faster, but they're much more expensive in terms of cost per gigabyte. With storage profiles, I can identify the storage characteristics of each one of my data stores, and then I can go to VMs and identify its storage needs. I can do compliance checks to make sure that my VMs that need fast storage in fact live on fast storage, or my VMs that don't need fast storage would benefit from high density storage live on high density storage. If my VM is out of compliance, it's living on the wrong kind of storage, and storage profiles can actually move the VM using storage vMotion to bring the VM back into compliance. I can make high availability clusters. HA clusters are clusters of ESXi hosts that watch each other's health. If a host fails, the HA cluster kicks in, reassigns the VMs off of the failed host onto surviving peers, tells the new owner, boot up your VMs. Your VMs are back in service in minutes, even though your server might be completely dead. HA clusters minimize VM downtime caused by unplanned server outages. If you want zero downtime, VMware has the capability of creating fault-tolerant VMs. Fault-tolerant VMs are part of HA clusters. You can declare a VM to be fault-tolerant, and if you do, VMware will take the VM, create a mirror image of that VM on another host, and then keep the CPU state and the memory state of the two VMs fully synchronized. If the host running the primary copy of the fault-tolerant VM dies, fault tolerance will detect the loss of the primary VM, promote the secondary VM to primary status, and just schedule it to run. It has the same CPU state, the same memory state, it's connected to the same disk, it has the same IP address, the same MAC address, and it's connected to the same network. It just keeps going, and all of the network peers have no idea there was just a failure. VMware also has workload migration and backup tools. It has vCenter Converter. Converter is a tool, turns out free to download, free to use, that can reach out to physically deployed machines or virtual platforms of any kind and suck that workload into a new vSphere virtual machine. It has data protection, which is a virtual machine snapshot backup and recovery tool. So I can take hot snapshots of my VMs, back up my VMs, I can do full image restores, I can do individual file level recovery, all with data protection. And vSphere Replication is a hot VM replication tool, so I can replicate my most important VMs either to ESXi hosts in my environment or ESXi hosts on a completely separate environment with a separate vCenter server, so that if God forbid my primary environment dropped dead, I could restore my VMs quickly and reliably on my DR site by just going to vSphere Replication, restoring the VM, booting it up, putting it back into service, and away we go. What about certification? Well, ESX Labs offers the opportunity for you to get certified. We have a certified virtualization specialist and technician cert. We offer exams for certification, and the idea here is to prove that you have the chops necessary to run somebody's vSphere environment. Our exam is online. It's free to anybody who takes this class. If you score 80% or higher, that will earn you an ESX Lab Certified Virtualization Specialist cert. If you scored between 60 and 79%, that will earn you an ESX Lab Certified Virtualization Technician cert. If you initially don't achieve certification or achieve certification at the technician level, you can always retest and see if you can upgrade yourself to specialist. The exam is available anytime after you've sat through this class. It's 75 questions. You get 90 minutes. It's mostly multiple choice, pick the best answer. There are some true and false. And you can use this as a practice exam for taking VMware's vSphere certification options, or you can use it just as a reality check to see how much information you actually gathered from sitting these classes. If you want to know more about our ECVS cert, please visit www.esxlab.com/ECVS capital O overview. Now, IT is all about vendor certification. Vendor certification is a way for you to demonstrate that you have skills, ability, knowledge, experience that the vendor recommends for the effective use of their products. VMware has a cert called VMware Certified Associate, or VCA-DV, where the DV stands for Data Center Virtualization. This is a new certification track for VMware. You do not need to take any kind of training to get this certificate. You just need to pass the test. So you don't need to take our training. You don't need to take VMware training. You can train on your own. You can do on-the-job training. You can just build your own skills and experience just by working, whatever works for you. You must register with VMware before you sit the exam. It's 50 questions. You get 75 minutes. If English is not your primary working language, they actually give you a little extra time. You must score 300 plus out of a possible 500 on the exam. Now, if you're not successful, then you can just, darn it, I'm going to take that exam again, and I'm going to do better this time. That's not wise. If you're not successful, you need to step back, assess your skills, assess your areas where you need improvement, invest more time and energy in building your knowledge, and then try again. And one of the reasons why you want to do what I just said is because the exam retails for about 120 US dollars. Now, we cover most of the things that you need for ECVS, and I'm sorry, VCA, Data Center Virtualization, but not everything. Okay? You also need to learn complementary products. So complementary products would mean learn the feature set of VMware Operations Manager and VMware Site Recovery Manager, because VMware will ask you questions about use cases for complementary products and how they fit in with vSphere. Problems and opportunities. As IT administrators, we face a number of challenges in our daily performance of our duties. I call them pain points. And the reason I call them pain points is because we deal with a lot of frustrating things, things that aggravate us, things that just sometimes drive us nuts. Point is that typical IT shops, depending on whose study you read, spend between 70 or 80% of their entire budget just keeping their servers running, the lights on, backed up, recovered, available for service. So we spend a lot of time provisioning new workloads, deploying new servers, managing existing workloads, operating systems, applications, storage, and so on, trying to improve our deployment through third-party imaging solutions that allow us to deploy Windows or Linux more effectively, making sure that our stuff is backed up, that we have disaster recovery procedures in place, and so much more. Well, it turns out virtualization provides solutions to these problems, and this overview class will explain how virtual infrastructure addresses our day-to-day problems. Now, there's lots of different ways to do it. We just don't want to throw new software into the mix just for the sake of adding more software. So this new software has to provide some value. And here's areas in which the value is provided. Virtualization provides new methods for doing things. These methods are often more streamlined, fewer steps. They involve much less risk. They will take a lot of the risk out of the day-to-day activities that we do. We can get results faster. Less time involved, less night and weekend time. I can actually reduce my overall IT spend with virtualization. I can simplify how things are done. There's way too many things we do in IT that are just needlessly complex or appear to be needlessly complex. So let's talk about some of the major issues that IT administrators face on an ongoing basis. Well, there's many. There's low server resource utilization. There's data center costs, space, power, and cooling. I have to pay for all that square footage. I have to pay to power the servers and cool the servers and so on. I have complex and obtuse OS and application deployment steps that I have to follow. I have to back up and be able to recover my entire workload or individual files and directories. Some of my tools that I use for doing that are expensive, complex, and not wholly reliable. PC servers have a short lifespan. 3 to 5 years after I buy a PC server, I need to pull it because its support contract is run out. Then I have to migrate the OS and application to another PC server, and 3 to 5 years later I'm going to be doing the same thing again. I want to be able to do remote access and support. Sometimes I have limits in terms of how I can do that. Virtualization gives me full access to all of my VMs, so I can provide the support I need from anywhere within and sometimes even outside of the organization if you allow for outside VPN connections. Hardware maintenance is much easier on virtual servers than on physical servers. I can actually reduce my spend on operating system licenses from our friends at Microsoft. I can do better disaster recovery planning with less cost and a higher likelihood of being able to successfully spin up my disaster recovery environment, bring up my workloads, and do it with less time and less aggravation. And I can support my organization's efforts in testing, development, training, quality assurance, and so on. So let's take a look at some of these issues in more detail. The key benefit of virtualization is more efficient resource utilization. Pre-virtualization, which means server utilization rates before I introduce virtualization, pre-server virtualization resource rates are typically very low. What does that mean? It means that, on average, I'm using only a fraction of the CPU, memory, network, and disk capability of the server at any time. One of the main reasons for that is because my typical deployment model is one OS and application per server. We'll talk about why that is in a minute, but the net result is this. Even if I provision my server with the critical resource properly sized, so if I have a PC server that's using 80% of its declared memory, that would be properly sized. I'm using most but not all, so I have some headroom in case I need it. The other subsystems are typically left lightly used. So if I'm using most of memory, I might be using CPU lightly, network lightly, storage capacity and bandwidth lightly. So that begs the question, why do we do one OS and application per server? Well, for isolation reasons. I'm going to talk first about political and administrative isolation. Political isolation means it's my box, just mine, nobody else's, everybody else stay off. That's not uncommon in most organizations. Administrative isolation is where an administrator basically goes, I don't trust any other administrator to manage this box correctly, so I'm not going to share the administrator password or the administrator duties. So I use it to run my application. There are other forms of isolation, like application isolation. Application isolation says I must install only one application per server, perhaps because my enterprise application vendor has told me, clear as a bell, that if there's other applications on the server, they won't honor my support contract, so I must dedicate a server to them. DLL isolation is an interesting problem. DLLs are dynamic link libraries. Are libraries of shared code that are meant to be used across multiple applications. And they do things like print drivers and other sorts of popular services. The problem is if I have multiple applications on a box, if I upgrade the first application, it might change the DLL and break the second application. So even though I can have the potential for shared code, it's usually just too risky to do. Here's another reason for dedicated machines, to simplify backup and recovery and disaster recovery. If I have one application on a box, if I back up the whole box, I've backed up the application and data. If I recover the whole box, I recover the application and data. And if I replicate the entire box to my DR site, I've replicated the application and data. With multiple applications on the same box, the problem is, how do I back up and recover all of application A without stepping on application B and vice versa? Now there's also the perception that PC servers are cheap to buy, to license, to run, and so on. And that's true of a small number of PC servers, but as your PC server population grows, you'll be surprised at how much money you end up spending on your PC servers. The solution, of course, is server consolidation through virtualization. And the idea is to deploy a relatively small number of physical PC servers, connect them to competent shared storage resources, place VMware's vSphere virtualization software on the servers, and then run all my workloads as virtual machines. My ESXi host needs to have enough CPU, enough memory, enough network bandwidth, and storage capacity and bandwidth to meet the combined resource demands of my VMs. But it turns out in today's world of high core count, high memory, high storage bandwidth, and high network bandwidth servers, it's actually not that hard to do. Now, the cool bit is my VMs compete against each other for available host hardware resources, CPU, memory, disk, network, and so on. What's critical is VMs do not get what they declare, they get what they need when they need it. So, for example, if a VM is idling, where the guest OS has nothing to do, it may be forced to give up its CPU and maybe even some of its RAM so that other VMs get access to those resources, which is fair because if I'm idling, I don't have anything to do. One of the things that this allows me is to overcommit my resources. Overcommit means booting up more virtual resources than I have physical resources. So an example would be more virtual CPU cores than I have physical CPU cores. This works because my VMs don't need all their CPU all the time, so when I'm idling, the CPU can be taken away from me and given to other VMs that have useful work to do. Now, my VMs share network bandwidth and storage bandwidth, so as long as I have enough, I'm good. Now, as administrators, we can resource tune our VMs. VMware has a number of weighted scheduling mechanisms for CPU, memory, and disk I/O, and this allows me to ensure that my most important VMs get the resources they need, and that my less important VMs will suffer resource starvation if I overcommit the host. Let's talk about some other issues. Let's talk about data center problems. Data centers are hugely expensive. Data centers consume an enormous amount of power, both to power servers and to run the chillers to take away the waste heat. They are some of the most expensive real estate your organization owns in terms of cost per square foot. If I run out of rack space because of all the PC servers I have, it costs a small fortune to build out or expand my data center. And that's really hard to justify in these days when budgets are scrutinized so carefully. Every time I deploy a new PC server, I have to find new enterprise storage switches or switch ports on my enterprise switches. I have to find shared SAN storage resources. I have to come up with backup and recovery procedures. I might have to buy agents or tools to install in my workload. I have to figure out how to disaster recover this workload, and I have to spend time administering it, configuring it, monitoring it, and so on. And I have to make an effort to try and ensure that I have configuration consistency. More on that later. So the solution in this case is don't deploy physically, deploy virtually. I can run, depending on the resource needs of my VMs and the resource capabilities of my hardware, perhaps as few as 5 VMs per host, or maybe 50 plus VMs per host. 10 to 20 VMs per host is very common in today's world of high horsepower PC servers. If I can take 10 old PC servers, use VMware Converter to bring the workload into a virtual machine and run it on my new ESXi hosts, I can retire 10 PC servers for every new ESXi host, or maybe 20 if I have more powerful hosts. That would significantly relieve my rack space congestion because I pull out 10 servers or more and put in one to take its place. One server will certainly draw less power and use less cooling than 10 servers, and it will allow me to better leverage my existing network resources and my existing storage resources. With fewer physical PC servers to administer, backup, network, and recover and so on, I have more time to focus on doing things that bring value to the organization and less time to spend on just babysitting my PC servers. Operating system and application imaging. So it's like this. If I buy a brand new PC server, I have to get the operating system of my choice installed onto that PC server. If my PC server has high-end networking or storage, I might have a real fight on my hands to get those drivers installed, configured, and working the way I want. So for example, I might have to install multipath drivers on my storage controllers to take advantage of the bandwidth to my SAN. I might have to set up complex NIC teaming configurations, and I have to do that for every PC server. This is time consuming, and it introduces needless variation and risk. Needless variation means I don't make the same exact decisions from a server to server, OS to OS basis. Sometimes I do it one way, sometimes I do it slightly different. The problem with that is the differences can introduce variation, and if I'm not mindful of that variation, I can do the wrong thing on the wrong server and cause harm. I can buy third-party imaging solutions. Ghost, Acronis, StorageCraft, LiveState, and so on. These are third-party tools that allow me to create OS hardware images and put them onto new PC servers. The problem is these imaging tools and the images I create from them are typically tied to a particular make and model of server. So the images may need a lot of maintenance if I change to a higher tier of server, a different product line of server, or if I change manufacturer. But if my workloads are virtual machines, all that goes away. Because VMs don't see the underlying physical hardware, VMs see generic PC server hardware. So VMs can use simple drivers, not complex drivers. It's really easy to create VM golden master images. This is for deployment purposes. I can rapidly deploy new VMs through clones, which is a one-time copy, or templates, which are VM golden master images made specifically for rapid VM deployment. What this means is my VM deployment model isn't deploy from scratch or set up some third-party imaging tool. It's take an existing VM, copy it to a new location, give it new properties, which is customize, boot it up, and put it into service. I can very easily create a whole library of ready-to-deploy VMs. Because they're virtual machines and not tied to hardware, they're much easier to maintain, and they will run on any ESXi host. So I can change model of server, I can go to the next generation of server, I can even change server vendors, and my VMs still work. What about backing up and recovering my workloads? Well, legacy backup and recovery tools also work in VMs. So legacy tools would be the old tools that we use with backup agents and backup servers and network-based backup. They all work just fine, but they were very expensive. They were sometimes really complex to set up, and they weren't always reliable, and sometimes they let you down when you needed them most. The problem is I would quite often have to load up on all sorts of agents, backup agents, recovery agents, application agents, open file agents, and buying licenses for all these agents just increased the cost of the tool. Now, VMware makes backup very simple. ESXi implements something called disk block change tracking. So what happens is as my VM runs, if it does a write to a disk block in its virtual disk, ESXi marks that disk block as changed, because it's been updated since it was last backed up. When it's backup time, what virtualization aware backup tools do is they snapshot the VM, which is grab a point in time state save of the VM. Then what they do is they go through all the changed disk blocks and they copy the changed disk blocks only to the backup repository. Once the VM's been fully backed up, the snapshot is committed and the VM just continues along its merry way. Actually, the VM continues along its merry way while all of this is going on, because the snapshot only causes a minimal interruption to the VMs that are in service. Later on, what I can do is I can restore the VM either in place or to a new location by simply going to my backup tool, picking the VM I want, the backup image I want as per available date and time, telling it where I want it to go, and say recover. I can even do file level recoveries by installing a file level recovery tool in my VM, which would allow me to backup or browse backup images for that VM and then cherry pick out the files I want. VMware has a tool that does this called data protection. They had a tool in vSphere 5.1 called data recovery that did this. Data protection has replaced data recovery. There are tools from companies like Veeam, PhD Virtual, that's now owned by Unitrends, and many, many others. These are very competent tools. They're very efficient. They're very fast. They have lots of features. They're easier to use, and most importantly, they're cheaper than legacy file and directory backup tools. What if I have to do a server refresh on a physical server? The problem is physical PC servers have a very short lifespan. The lifespan is usually somewhere between 3 and 5 years, and it's quite often dependent on the length of the service contract you buy when you buy the PC server. Now, the challenge is when the PC server is end of life, you have to somehow migrate the OS application and data from the old server to the new server. And there's no operating system that makes that easy. Windows, it's a challenge to do in Windows, it's a challenge to do in Linux. Using traditional techniques, I have to take the workload down, I have to migrate it to the new server, I have to configure it, I have to bring it up, I have to test it. I'm probably doing this off hours. I'm probably doing it while I'm sitting in the computer room, and it is very risky. Things could go wrong. Lots of different things could go wrong. So the virtual solution is based on the fact that VMware doesn't use physical hardware. Virtual machines use virtual hardware, which is independent of the underlying physical hardware. This means that I can replace an ESXi host by taking advantage of VMware features like hot and cold migration, where I just migrate my VMs from the old host to the new host. What this does is it limits downtime to either the migration time if I'm doing cold migration, or to no downtime at all if I'm doing hot migration. So from a high level perspective, here's what I would do. I would provision myself a new PC server. I would install ESXi on the new server. If I have clusters, I would join it to the cluster. I would migrate my VMs off the old host to the new host. When the old host is fully evacuated of VMs, I would shut it down, remove it from vCenter. I would then wipe it clean, box it up, send it back to the vendor. And the neat thing is I can do this with no downtime. I can do it remotely. I can do it with no risk. Many of the ESXi hosts that are put into the field are put into the field specifically to run Windows VMs more efficiently. And it turns out that there's some specific licensing information you need to have in order to ensure that one, you're correctly licensed, and B, you're not spending any more money than you have to get the Windows licenses you need. So first I'm going to talk about Windows Server 2003 and 2008 because they both use the same licensing model. Some Windows editions have very friendly licensing from a VM point of view. So here's the way it works. If I use Windows Server Standard, then I have to buy a license for every VM. So I'm paying standard licenses for every VM. If instead I go up to Windows Server Enterprise, then I only need to buy one license for every 4 VMs. Microsoft gives you the right to run that one license in up to 4 VMs. So now what I've done is I take Server or Enterprise, which again is more expensive than standard, but if I run it in 4 VMs, I cut the price per VM by 4. Where I really save is with Windows Server Data Center. Data Center is Microsoft's top tier license. Now, they have very VM friendly pricing. So what that means is this. I have to license Data Center not by the VM, not by numbers of VMs, but by the number of CPUs I have on my physical servers. Each CPU requires a license, and that license entitles me to run an unlimited number of VMs on that CPU with no extra charge. So if I have 4 hosts with 2 sockets each, if I buy a total of 8 data center CPU license entitlements, I can run as many VMs as I want on any CPU I want, on any host I want, anytime I want. I can spin up new VMs, I can vMotion them back and forth, and I can do this and remain fully licensed. Now with Microsoft, the challenge is always understanding your license terms and conditions. One of the things you should be doing is not using retail keys or OEM keys, but volume license keys or multiple activation keys, and you should always check the verbiage of your license to make sure that you're using it in the most efficient way possible. What I just said about Windows Server licensing doesn't apply to 2012. Server 2012 has different license tiers. They still have Standard Edition, but Standard Edition entitles us now for Server 2012 to enable 2 physical sockets per license and no more than 2 VMs per license. If you want more than 2 processors on a physical machine, or you want to run more than 2 VMs on your physical machine, you need to buy a new standard license for each new pair of processors or each new pair of VMs. Enterprise Edition is gone. You can't buy it anymore. There's Data Center Edition though, and Data Center now includes 2 physical CPU license entitlements for the cost of the license. For every pair of physical CPUs where you hold a Data Center license, you can run an unlimited number of VMs on that machine. So if I have 4 machines, I buy 4 data center licenses. That entitles the 2 CPUs on each machine. I can then boot up and run any number of VMs I want on any machine I want. I can vMotion them back and forth, and I always remain fully license compliant. Now, the information I'm giving you is from a PDF document called Windows Server 2012 License Pricing FAQ. I got it from Microsoft's download site. You might want to do a search for this document and read about the latest terms and conditions for licensing Server 2012. It turns out virtualization is a huge benefit when it comes to disaster preparedness and recovery. Here's the challenge. As custodians of the corporate IT infrastructure, the responsibility falls on us to ensure that we can maintain business computing continuity even in the case of an IT disaster. And you might go, well, IT disasters don't happen, and I would politely beg to differ. In my career, I've seen 3 rainstorms in a computer room, I've seen a flood in a computer room, and I was fortunately not in the computer room of one company when the enterprise power unit exploded. Disasters happen. Now, the typical way of doing disaster preparedness is to replicate your entire data center to a DR site. The problem with replicating all of my hardware and software is that it's costly and it's enormously expensive. It's also hugely complex. I have to create disaster recovery procedures, I have to test them, review them, refine them, and retest them. This is an ongoing process. Now, what's the risk? If I don't do this, if I don't have a tested, reliable DR plan in place, according to the CPAs, a professional body of accountants in the US, a study of mid-sized businesses whose revenue was somewhere between $50 and $500 million a year, who experienced an IT disaster, had businesses going out of business within 6 months of the IT disaster if there were no DR plans in place. 80% gone. If, on the other hand, they did have disaster plans in place, tested, reviewed, there is an 80% chance that business would still be in business after an IT disaster. Now, virtualization significantly helps in preparing your disaster recovery strategy. If I have storage appliances, then higher-end storage appliances include SAN LUN replication. SAN LUN replication says whatever happens to LUN 1 on my production SAN, make it happen to LUN 1 of my disaster recovery SAN. So all writes that are posted to LUN 1 of my production SAN are replicated and posted to LUN 1 of my DR SAN. You can pair that capability with VMware's Site Recovery Manager product, and what it will do is it will replicate your VMs to your DR site and keep them up to date. So if your production site drops dead, you can simply spin up your VMs on your DR site, all the data is up to date, you just keep running the business as usual. Now, if you don't have this feature, and maybe you can't afford it because you're not that big, or your budget isn't that big at least, VMware has a more tactical solution called vSphere replication. This lets you duplicate the VMs of your choosing to a site within your organization or to a different physical location. It periodically synchronizes the virtual disk and other file images of your VMs from your source production environment to your DR site by replicating the changed disk blocks of the selected VMs. This feature is included in many vSphere licenses, and it can be a real lifesaver if you have an IT disaster in your production environment. In one of our future courses, I'll show you how to set up, configure, use, and recover vSphere replication. VMware vSphere is of enormous benefit to managing and running your production workloads. But what about all your non-production work, like your testing, your development, your quality assurance efforts, your training efforts, and so on? Well, traditionally, development environments, test environments, and so on did not match production environments, primarily because it was too costly to replicate the same hardware exactly. The challenge that introduced was that you could end up with variations between your test and production environments, so that made it harder to validate changes, service packs, upgrades, application upgrades, configuration changes, and so on. And so you could end up in situations where it worked in test and development, but it doesn't work in production, taking your production systems offline. Well, with virtual machines, all of this becomes almost trivial. One of the features VMware offers is the ability to hot clone a running VM. A clone is a one-time copy of a VM, and a hot clone is made while the VM is in service. The clone is an exact copy of that VM at that moment in time. So if I can clone a VM, then I can do testing, change management, upgrade testing, and so on the clone, do everything I need, validate my changes, and so on, knowing that if it works on the clone, it will work on the production machine because it's the same machine. Now, one of the other challenges when I'm doing any kind of testing is if the testing goes sour, how do I restore the machine back to its pre-test state? And the answer in a virtualization world is snapshots. A snapshot, again, is a point-in-time save of a VM. So before I make any changes, I snapshot, which saves the VM state. If anything goes wrong, I just revert back to the saved state. I just throw away my changes. I don't need to re-image the VM. So if something does go wrong, I just revert back to the saved state, power the VM on, and go again. And I just keep doing this until I solve all my upgrade, patching, reconfiguration problems. I document everything, and then during a maintenance window, I just go through the same steps on the production VM, and I know it's going to work because I did exactly the same thing on its clone. Now, I just talked about the benefits that your organization will reap from using virtualization technology. What about the benefits to you as an IT professional? Well, it turns out virtualization is a hot topic. So what I've done here is I've gone down to a website, payscale.com, specifically done a search for virtualization skills, and what we see here are virtualization or job categories that require virtualization skills, from system engineer to senior system administrator to information system architect and solutions architect. And these are in-demand jobs that pay at or well above industry averages. And one of the things they have in common is they all require virtualization. Now, in this case, this is not just unique to VMware virtualization, but VMware is the major player in enterprise virtualization, so adding VMware skills to your resume is a very wise thing to do. Okay, let's take a look at how virtualization capabilities have grown over time. So what I have is different editions of ESX and ESXi going all the way back to the first edition, which was released 14 years ago in 2002. In the first release of ESXi, our VMs could only have single core virtual CPUs. They could only have 2 gigs of RAM max. They could only have 500 megabits of I/O bandwidth, 5,000 storage I/O operations per second, and the physical server could have no more than 4 cores. That's it. Move ahead to 2005, and now my VMs could have 4 cores, 64 gigs of RAM, much higher network I/O bandwidth, and much higher storage I/O bandwidth. My PC servers could be bigger with 96 cores, and they could have up to 256 gigs of RAM. Move up to vSphere 5.0, which was released in 2011, and my VMs can now have 32 cores. They could have up to a terabyte of virtual memory. I can have more than 36 gigabits of network I/O bandwidth, more than 1 million I/O operations per second, but that would require very expensive SANs, up to 160 cores on my physical server, and 2 terabytes of RAM on my physical server. We're going to jump to 2013 when vSphere 5.5 was released, and now I have the ability to have VMs with up to 64 virtual CPU cores. That would be VMs with 8 sockets at 8 cores per socket. My VMs can have up to 1 terabyte of RAM, 80 gigabits of network bandwidth, and a million I/O operations per second. I can have up to 320 physical CPU resources in a host and 4 terabytes of RAM. The point is, VMs have gotten so big and so fast over time that performance is no longer a barrier to virtualizing workloads. Okay? There are no longer capacity and performance limitations. So you wouldn't, in the past, you might go, well, I don't really want to virtualize Exchange, or I don't want to virtualize SQL Server because it's really big. But now, how many workloads do you have that need 64 cores, that need a terabyte of RAM, or more than 80 gigabits of network bandwidth, or more than 1 million I/O operations per second? VMware brings enterprise class resources to VMs and enterprise class performance to VMs. Now, we've already talked about VMware license tiers in the introduction to this class, so I'm going to cover it again very briefly. VMware has small business-oriented licenses, specifically Essentials and Essentials Plus. In the vSphere 5.1 space, they have Essentials Plus with the vSphere storage appliance, but the vSphere storage appliance has been essentially replaced by vSAN. So I can have up to 3 hosts on all license tiers, no physical limit on the number of cores per CPU. I can buy CPUs with as many cores as I like. I can have up to 3 physical PC servers managed by my vCenter appliance, and I can have VMs with up to 8 cores per VM. If I have Essentials, that's all I can have. I can have failure recovery clusters, backup and recovery, hot VM migration from host to host to balance out CPU or memory resources. I can do vSphere replication. I can do vShield endpoint antivirus and network security, and I get hot plug hardware, and that's available in Essentials Plus. Now, these prices are somewhat dated. Your prices may vary by region, and you should always check the latest vSphere pricing documents that VMware publishes to find out what your retail prices are. Now, don't be shy about asking your partners for discounts. VMware is aggressively sold by many partners, and it's not uncommon for partners to offer discounts to win your business. We've also talked about VMware vSphere 5.5 editions at the introduction of this course, so I'm going to go through this very quickly. There's free ESXi, which is essentially a standalone ESXi host that cannot be managed by vCenter. You can have any number of VMs up to the hardware limit, which is what your hardware can reasonably do. I can have as much RAM as I want. My VMs can have up to 8 cores. I can use VMware's cluster file system. I can back up and recover my VMs with data protection, and I can patch and update my hosts. If I upgrade to vSphere Standard, the additional features I get is the option of vSphere Storage Appliance, or vSAN now. I can do backup and recovery. I can do high availability clusters for rapid failure recovery of my VMs if a host dies. I can do vShield endpoint antivirus, which is virtualization aware antivirus. I can do hot replication with vSphere replication. I can do hot migration with vMotion. I can do network security with vShield zones. I can do fault tolerance, but only VMs that have one virtual CPU core. And I can do storage migration with storage vMotion. If I upgrade to vSphere Enterprise, I can now make VMs with up to 32 cores of virtual CPU cycles. And on top of all the features Standard brings, I can do high reliability for memory, which allows my high-end PC servers to continue running even if there's a complete memory failure of part of my memory subsystem. I get extra extensions for managing big data applications like Hadoop more efficiently. I get DRS CPU and memory load balancing clusters, and I get DRS power management. And power management is an extension of DRS clusters that says, you know, during off-peak hours, I might not need all the hosts in my cluster to easily meet the resource needs of my VMs. So if I'm way over provisioned during off-peak hours, move the VMs off a host, shut it down. Maybe move the VMs off a second host and shut that one down too, if I still have lots of spare resources. The neat thing is a powered off host doesn't burn any CPU, or doesn't burn any power, doesn't produce any waste heat. So literally the server turns off. And what's cool about power management is as you go back into production hours and the load goes up, power management will monitor the load, and when it sees it might need some help, it'll wake up one or more of those sleeping hosts, boot them up, put them back into service, reinsert them into the cluster, and then just distribute the VM workload across that host. So essentially the cluster shrinks as resource demands diminish, and the cluster grows as resource demands grow. Now, if you have vSphere Enterprise Plus, then you have VMware's top tier license. This entitles you to make VMs with up to 64 virtual CPU cores organized as 8 virtual sockets with 8 virtual cores per socket. I get all the features of vSphere standard, but I also get vNetwork distributed switches, which are virtual switches that span multiple ESXi hosts. They're created, managed, monitored by vCenter, which means I only make them in one spot, not once per host. I get the ability to control network and storage bandwidth. So I can set up scheduling policies that basically say what bandwidth can my VMs use to storage under storage bandwidth contention, and likewise with networking. I can use host profiles to set and enforce host configuration rule sets to ensure that all my hosts have a configuration that I approve of. I can do auto deploy to boot my hosts off the network, which is useful on large environments where I don't want to have RAID cards and disks in each host. I don't want to be upgrading each host individually. And I can do storage DRS for storage capacity and bandwidth load balancing, and profile-driven storage so that my VMs that need high performance, expensive storage are kept on that storage, and my VMs that can get by with high density, lower cost storage are gently moved over to the appropriate storage resources. Let me talk a little bit more about vSphere licenses. VMware sells licenses in something it calls an acceleration kit. An acceleration kit is a set of vSphere license entitlements, and they're typically offered at a discount over the standard a la carte prices for, say, ESXi and vCenter. CPU license entitlements are sold in bumps. So a bump is, here's your first 6, here's another 4, here's another 8, whatever it is you happen to need. The minimum entitlement for an acceleration kit is an entitlement for 6 CPUs. Now, in some licenses, I can buy upgrades that entitle me to go to 8, 10, 12, as many CPUs as I want. Small Business and Small Business Essentials Plus do not include the ability to go beyond 6 CPUs. So in that regard, they are constrained from the number of CPUs that you can actually use in your vSphere environment. So the acceleration kit name is Small Business Essentials. This is the entry-level kit. It entitles me to use 3 hosts. There's no vSphere storage appliance. I must have no more than 2 CPUs per host, no more than 8 VMs per, or 8 virtual CPUs per VM. Essentials Plus gives me many more features, but it still has the 3 host maximum. I have the option of the vSphere storage appliance. I'm still restricted to 3 hosts and no more than 2 CPUs per host, and I can have no more than 8 virtual CPU cores per VM. Now, a more flexible acceleration kit is vSphere Standard. I get vCenter Standard, which means that I have all the vCenter features to manage my ESXi hosts. I can optionally get the storage appliance. I start with 6 CPUs, but I can buy license bumps that entitle more CPUs as my workload demands grow. Again, I can only have VMs with 8 virtual CPU cores per VM. I can get vSphere standards with operations management. Standard with operations management includes the operation management capability. Operations management is an add-on tool that allows me to determine if I've right-sized my hardware, if I've right-sized my VMs, if there's any problems with respect to capacity, bandwidth, and it alerts me before things get bad. So the idea is operations management is essentially my operator assistant that tells me about things that are potential problems before they become real problems. Again, the acceleration kit starts with 6 CPUs, and because it's based on a vSphere standard license, I can only have 8 virtual CPU cores per VM. I can have enterprise acceleration kits, which give me access to all the features of the vSphere Enterprise license tier. Again, I start with 6 CPUs, and I can have VMs up to 32 virtual CPU cores, and I can buy Enterprise Plus acceleration kits, which give me access to all the features in Enterprise Plus. I also start with 6 CPUs, but now I can make VMs as big as 64 cores. Now, there's something you need to know about vSphere licensing and acceleration kits. Acceleration kits typically include a fixed number of CPU entitlements, so they all start off with 6. They include a single vCenter server license entitlement, and they may or may not include additional license entitlements for add-on features like storage appliance and operations management. I can add physical processor entitlements to some acceleration kits, but not others. So the idea is if I outgrow my 3 servers, if I have vSphere Standard, Enterprise, or Enterprise Plus acceleration kits, I can buy new CPU entitlements so I can add more servers. I cannot buy CPU entitlements for Small Business Essentials or Essentials Plus. They max out at 3 servers and they insist on 2-socket servers only. I can't have a 4-socket server paired with a 2-socket server. Okay? So I have a maximum of 3 ESXi hosts. This is a major limitation, but it keeps the price down. Now, one of the things I get when I buy VMware licenses is I get access to their service and support called S&S. These are support contracts, and support contracts are mandatory for all vSphere license tiers. Now, I can buy different kinds of support. I can buy 1 year business day support, in other words 8 to 6, or I can buy up to 3 years of 24/7 support. All support tiers are unlimited in that there's no per incident charges. You can't run out of support incidences. If you have problems, you call VMware, they will help you. Support also entitles me to new versions of ESXi. So if I have ESXi licenses and VMware goes up to a new version, then I can cash in my old licenses for the latest version as long as my licenses are under valid support contracts. So in other words, if I'm running vSphere 5.5 and VMware releases vSphere 6, as they'll do probably in 2015, as long as I have a valid support contract, I can upgrade to vSphere 6 whenever I'm ready. If my support has expired, then things are bad. I cannot upgrade across major releases. So VMware uses a different license key generation mechanism for vSphere major editions. So in other words, license keys that work in vSphere 4 don't work in vSphere 5, and it's likely that license keys that work in vSphere 5 do not work or will not work in vSphere 6. I can upgrade across minor releases. So I can use the same license keys to entitle vSphere 5.0 and then upgrade to 5.1 and then upgrade to 5.5, but I can't cross major releases. Now here's where things get ugly. If I'm out of support, if I'm a VMware customer and I'm out of support, and I want to get back into support, I can reactivate my support, but it gets really expensive. The last time I checked, VMware's policy for getting back into support required that you do 3 things. You first of all pay for all of the years when you didn't have support. So if you've been out of support for 2 years, you have to back pay for support for the last 2 years, even though those 2 years are gone. You have to buy at least 1 additional year of support. So that's a year going forward. And then you have to pay a penalty on top of that, essentially as a discouragement for allowing your licenses to go out of support. So the moral of the story is keep your licenses in support. You can then rely on VMware to help you out if things go bad, and you'll always have access to the latest, greatest versions of VMware software. Now let's take a look at VMware's hypervisor, and the name of the hypervisor is ESXi. ESXi is enterprise-class server virtualization software for bare metal installations. What I mean by bare metal installations is this. ESXi installs on industry-standard Intel or AMD-powered PC servers. The core of ESXi is an operating system component called the VM kernel. The VM kernel is the OS core for ESXi, just like the Linux kernel is the OS core for Linux, and the NTOS kernel is the OS core for Windows. It includes a VM task scheduler that takes physical CPU resources and uses them to meet the CPU needs of VMs. There's a memory manager that takes physical memory resources, converts it to virtual memory, and uses it to meet the memory needs of VMs. There's a network subsystem that consists of virtual NICs and virtual switches that uplink to physical networks through associated physical NICs. And there's a storage subsystem that gives my virtual disks access to backing physical storage, either local SATA, SAS, or SSD-based storage, or SAN or NAS storage. Now, the point is the VM kernel dynamically load balances VM resource demands against available physical resources. It assigns, for example, CPU and memory to VMs when needed, as needed, and can steal it back if it's not needed. If resources are scarce, the VM kernel might force idling VMs to wait instead of giving them CPU service, and you can dynamically tune your VMs to indicate which VMs are relatively more or less important, and that improves or reduces their scheduling priority when resources are scarce. Let's suppose I was interested in server virtualization, but in IT, quite often things sound better than they are, and then when you actually get into them, you find out that they aren't quite as good as they were represented. So let's suppose I chose to install ESXi onto just one host. I can then make a few VMs, as I have here. I have 3 VMs. They share the host's CPU resources, memory resources, disk and network resources, and so on. I can manage this host directly with the vSphere client. vSphere client is a Windows client that you point at the host and you interact with the host through a nice, easy to use GUI rather than complex command line tools. I can run free ESXi, or I can get low cost editions like Small Business Essentials or vSphere Standard. Okay. Now, I immediately reap some benefits. I've only bought one server, but I'm running multiple VMs. Because I've only running one server, I'm using less electrical power, I'm using less cooling. I can deploy VMs faster than physical machines, and I can upgrade VMs faster than physical machines. I can boot them faster, and I can do a bunch of other things with them. It's instantly more beneficial. Now, in business, if you do something and it works out well, you want to do it again. So I might choose to install ESXi on multiple PC servers and maybe go so far as to even provision a shared storage appliance. So here's my ESXi host. Maybe that host is running 2 VMs here, and maybe the host on the right is running 2 more VMs here. I'm sorry, 3 more VMs. I have a shared storage appliance, and I've carved out one LUN for each host. I can simply migrate my VMs onto shared storage from local captive storage. And the neat thing about this is now the VM's availability is not tied to the health of an individual host. So if I'm on local captive storage here, for example, and the host goes down, my VM's offline until I bring the host back. But if I live on shared SAN storage and my host goes down, then the surviving host can reach out to that shared SAN volume, find the VMs that are there, take ownership of them, boot them up, and put them into service. As a matter of fact, I'll show you how to do this in the upcoming upcoming chapter on virtual machines. Now, I don't have VMware's more sophisticated features like vMotion, load balanced, and failure recovery clusters and so on, but I've already introduced some fault-tolerant capability because if, as I said, a host were to fail, I can use a feature of the vSphere client called the data store browser to go over to the data store that held the VMs from the failed host, take ownership of those VMs, which essentially adds them to the surviving ESXi host inventory. I can then boot them up and put them into service. I can build my own private cloud with VMware vSphere. I take the same things that I just talked about, my ESXi hosts, my shared storage, my VMs, and so on, and I can introduce central management through vCenter. vCenter can run either on Windows or on Linux. In this case, we've chosen to illustrate vCenter on the Linux-based vCenter server appliance. vCenter needs a database for holding configuration and historical performance data. And vCenter becomes a management console for my ESXi hosts, my VMs, my network, and storage. It maintains a task and event log so I can see who did what when. It maintains vCenter logs so I can see what vCenter did. I can cold migrate VMs, even with the most inexpensive vCenter editions. I can monitor my VMs, hosts, and so on for storage capacity and storage for capacity, health, state, and the like. And there's a task scheduler so I can do tasks when it's most convenient, not when I'm just sitting in front of the computer. And vCenter is a necessary prerequisite to use the advanced features that VM offers, like hot migration, storage migration, high availability clusters, load balance clusters, fault tolerant VM configurations, backup and recovery, and so much more. Now let's talk about private cloud computing in a little more detail. There are lots of vendors out there that talk about cloud computing and how their products are cloud compliant, and they have different spins on what cloud means. I'm going to talk about cloud from the idea of running your own facility at your own company with VMware vSphere as being the software that enables your servers and storage and network and so on to build a cloud for your private use, an on-premise cloud. The key difference between legacy provisioning and cloud provisioning is cloud provisioning is dynamic. Dynamic means that provisioning allows you to provision what's needed, when needed, for, and here's the kicker, as long as needed. Not all my workloads need to be in service for 5 years. Some might need to be in service longer. Some might only need to be in service for a few days as I'm doing testing and so on. So what happens is cloud computing takes physical hardware, abstracts that hardware, and I'll explain how in a minute, and then shares it out. So storage was the first cloud service, if you will. And I don't mean cloud services like Box or Amazon. I mean the ability to consolidate hardware and then make it available to multiple machines. So storage area networks have been around for about 25 years. And the idea is instead of provisioning storage centrally, individually on individual servers, I provision storage centrally on my storage appliance. I can stuff the appliance full of disks. I can organize those disks into storage pools, which are essentially RAID arrays, and I can carve up those storage pools into storage volumes called logical unit numbers, or LUNs. I can make LUNs on demand, I can grow LUNs on demand, and I can present them to one or more servers as I see fit. LUNs can be used by ESXi hosts, partitioned, formatted, and so on, to act as a repository for VMs and for other storage needs. I can then take PC servers. Instead of just putting Windows or Linux on it and putting it into service, I install ESXi, which turns your PC server into a virtualization engine, which is to say a machine that runs virtual machines. Just like installing Windows and Exchange turns your PC server into an email engine, or Windows and SQL Server turns your PC server into a SQL database engine. I want to size my servers for high VM tenancy. That means I want high-end CPUs, I want lots of RAM, because I want to stuff a lot of VMs on this host. So what do? Well, I provision some ESXi hosts, I put them into service, I build VMs, and over time, as my VM population grows, I can simply provision more ESXi hosts and swing VMs over to these new hosts, which dynamically balances my load. If I have DRS clusters, I can automate this process. So I just add servers and the cluster just rebalances. And from a networking point of view, I don't want to be working with individual hosts on setting up and configuring and monitoring and upgrading networking. I can do it centrally through distributed virtual switches. These are virtual switches that VMware offers in its top tier licenses that span multiple ESXi hosts. I dedicate NICs, one or more NICs from each host, to the DV switch to act as uplinks between the virtual switch and the physical switch. If I dedicate multiple NICs, I improve the bandwidth speed and I improve reliability, because if one NIC fails, traffic can just swing over to another NIC in the team. The benefit of this is consistent network configuration, metrics that survive vMotion migrations, the ability to back up and recover my configurations. I can do port shadowing, a whole lot more. So let's take a look at a storage cloud. A storage cloud is essentially a storage area network. A storage area network is a storage appliance. Here, I'm drawing it logically as a device that has volumes that it can share out, a storage network that links storage controllers to the storage appliance, and then storage controllers that I install on my individual ESXi hosts. I can then take my physical disks, stuff them into shelves on the SAN, use the SAN's management tools to organize them into redundant storage pools, and then carve LUNs or separately addressable storage volumes off those LUN or off the storage pool. Those are called LUNs. I can present those LUNs to one or more ESXi hosts. And I say one or more because I'm going to partition and format those LUNs VMFS. VMFS is VMware's cluster file system, which provides safe concurrent active-active access by multiple hosts to the same LUN at the same time. I can simply add physical storage as my capacity demands grow. I can add storage controllers and upgrade my storage network as my bandwidth demands grow. I can provision LUNs on the fly. I can use the SAN's management tools to snapshot LUNs for backup purposes, and I can use the SAN's management tools to shadow, which is to say hot replicate LUNs, over to a disaster recovery SAN so that all the updates in my production SAN LUNs that are critical to me are replicated in real time or near real time over to my DR site. Now, what about a server cloud? A server cloud, from a VMware point of view, is a group of ESXi hosts that cooperate to run your VMs. Typically, you would organize them into a cluster. And the point is you would size your servers to meet the capacity, recovery, and performance needs of the VMs that you need to run. So I would install servers, or provision servers, install ESXi. I could, if I have a licensed entitlement, create DRS clusters, and DRS clusters are groups of ESXi hosts that load balance VMs across servers by doing vMotion migrations. The point is, for example, if there's too many VMs on host 1 and it's suffering resource contention, some of those VMs can move over to host 2, who might have spare resources. If the cluster as a whole is overworked, I can simply add a new host, connect it to the SAN, install ESXi, connect it to my common networks for production, storage, backup management, and so on, add it to my cluster, and VMs will immediately swing off of the busy hosts over to the new host, and the workload across the hosts in the cluster will go down. So when I provision a new host, every VM benefits through reduced competition because there's more resources available. If my cluster is a high availability cluster, then it doesn't do load balancing. But what it does do is it says, hey, HA, I'm here. If any of those other hosts fail, you can send their work to me and I'll do it. Now, in a vSphere environment, a network cloud is a distributed virtual switch. That acts like a layer 2 software switch that spans multiple ESXi hosts. On the virtual side, here we go, on the virtual side of the switch, I can have management ports on my ESXi hosts and I can plug VMs in. I can also have VM kernel ports, which are ports that the VM kernel needs to talk to peers on the network. I must uplink each host to a common layer 2 collision domain with a minimum of one physical NIC and possibly multiple physical NICs. Multiple NICs would give me more bandwidth, more reliability, and so on. And there are different NIC teaming strategies that I can use that we'll talk about later on. Now, there's a convention that I use in my class, and the convention is if you see a picture of something and it looks like physical hardware, it's meant to represent real physical hardware in your PC server or real network gear and so on. If you see a picture of something and it looks like a cartoon, like this NIC does and like this switch does, it's meant to represent virtual hardware. Distributed switches provide a unified view of the entire network configuration, including VM kernel ports and port groups, across all ESXi hosts. So I have a simple configuration, it's consistent across all hosts, and it's very easy to make a vMotion compatible configuration. It presents a common ARP table, or MAC address table. A MAC table on a switch is which MAC addresses are behind which ports, which makes it easy for the distributed switch to forward frames to the right port so that the frames are forwarded to the right VMs or physical peers. And it supports internal private VLANs, which is the ability to build a VLAN in a VLAN so that you can isolate VMs across hosts by just using one VLAN tag number. Now I want to talk about some of the capability that's new in vSphere 5.1 and 5.5. I'm using 5.1 and 5.5 because some of the features in 5.1 didn't get a lot of publicity, or you just may not be aware of them, so it's good to know these features are there. First of all, ESXi can support the largest hosts that your company can afford and probably something more. So ESXi has been designed and tested to run on hosts with 320 physical CPU resources. That would mean up to 320 cores or hyper-threaded logical processors. That's a massively huge physical machine. It can support up to 16 NUMA, or non-uniform memory architecture nodes. A NUMA node is like a microblade. It's 2 CPUs and local memory. And VMware is smart enough to move the memory image of VMs into RAM that's local on the CPUs that are running the VM. So in other words, my VMs will move to memory that's local to the NUMA node that's running my VM. Your VMs will move to the memory that's local to the NUMA node that's running your VM. This allows the hardware to scale very efficiently. ESXi 5.5 supports end-to-end 16 gigabit fiber. That means 16 gigabits from the host to the fiber switch and 16 gigabits from the fiber switch to the back-end SAN. It supports really big VMs, up to 64 virtual CPU cores per VM, up to a terabyte of virtual RAM per VM, up to 512 powered-on VMs per host, and up to 4,096 powered-on vCPU cores per VM, per host. It supports USB devices in VMs. It can essentially broker through physical USB devices on your physical ESXi hosts or your desktop, even if they're USB 1.1 devices or USB 2.0 devices, and if your guest OS supports it, even USB 3 devices. Again, I can plug my physical USB devices into either my physical ESXi server, or using your desktop, I can broker local USB devices through to my VMs. Continuing on with what's new in vSphere 5.1.5.5, VMFS has been improved. VMware in vSphere 5.5 with Virtual Hardware version 10 supports physical volumes up to 62 terabytes and raw device maps, which are map sandluns presented directly to a VM, up to 64 terabytes. It supports virtual disks up to 62 terabytes, and there are no longer any block per file limits that VMFS 3 had. It supports solid-state drives, which can be used in many different ways. Solid-state drives can be used as an ESXi host cache for improving SAN read efficiency by caching frequently read data onto a local SSD, so I don't need to constantly go back to the SAN to reread that information. I can use VMFS formatted local SSDs as a paging volume so that if I run out of physical memory and I need to page my VMs, I can page to fast local SSD storage, not to my SAN. And in vSphere 5.5, SSDs are even hot pluggable. I can disable them, pull them out, replace them, re-enable them, and put them back to work. vSphere replication has been vastly improved in vSphere 5.5 and simplified so that I can more easily hot replicate VMs to another host or another site. Additional features in vSphere 5.1.5.5, I can now storage vMotion VMs with snapshots. Previously, if a VM had a snapshot and I tried to hot move it to a new data store, without telling me, it would commit the snapshot, move the VM, and then if I ever tried to revert, I couldn't. That was a very unpleasant surprise. VMware is moving to web-based client tools as opposed to Windows-based client tools, and the idea is to improve the administrative interface to make new features and functions available through the web client while continuing to support legacy features and functions that vSphere client has always had. One of the features I can, for example, do in Web Client that I can't do in vSphere Client is in Web Client I can simultaneously, at the same time, vMotion a VM from one host to the next while I'm storage vMotioning it from one data store to the next. So in other words, I can basically say CPU and memory go to host 2 while storage go to LUN 3. That's just amazing, and it works really well. VMware has introduced the vCenter Server appliance. In the past, I had no choice but to run vCenter on Windows Server, which meant every vCenter install burned a Windows Server license. Now I can simply import a SUSE Linux appliance, enable vCenter, and go. I don't even have to buy a database engine anymore because it comes with the excellent open source PostgreSQL database baked right in. Now, if I'm using the vCenter Server appliance, I can still connect to Oracle databases, but not to SQL Server databases. And another feature that's available with vSphere 5155 is auto deploy. For really large shops, auto deploy is just a lifesaver. Auto deploy lets me install, boot, and run ESXi from the network. So what I do is I use auto deploy to create an install media image. I use DHCP to assign fixed IP addresses to my server. I use TFTP to download the media image to my host at boot time. I use host profiles to download and set a host configuration. And literally, I just power on my machine. I have it PXE boot. It gets all of its operating system and configuration information from the network. It just boots up and runs. VMware does stateful caching, where the OS image is written to local disk in case on reboot the network is not available, or stateless caching, which still writes the OS image to local disk. Stateful caching says write the disk image to local disk and use that in the future, and stateless caching says write the operating system and configuration to local disk, but continue to boot off the network if network boot is available. If it's not, it's okay to boot off local disk. So it's a safety net in case network boot is offline. There are even more features available in vSphere 5155. One of them is Virtual Hardware version 10. Virtual Hardware version 10 is the latest virtual hardware, essentially motherboard capability for virtual machines. It supports shared access to very high-end AMD and NVIDIA GPUs. So that means you can make VMs that have access to hardware-accelerated graphics, so you can run graphics-intensive applications like AutoCAD and Photoshop and all of that in a VM, and it works. There's huge improvements to distributed switches. There's health checks. Basically check to make sure configuration changes don't break the network before you apply them. There's configuration change rollback. If a configuration change actually does break the network, then what happens is the host and vCenter roll back to the last known good configuration, so the impact of a configuration error is minimized. I can back up and restore my distributed switches. My distributed switches live inside the vCenter database, which means if I have a catastrophic vCenter failure, my entire network is gone. I could then just simply recreate a new vCenter server, restore my distributed switch, and now my network's back. I can do not only Ether channel NIC teams, but now I can do LACP NIC teams, and I have improved vSwitch port replication capability. There's vShield endpoint for hypervisor-based antivirus protection, which is much more efficient and much more cost-effective than traditional server antivirus. And I can also save and restore resource pool configurations, which is useful because if I disable my resource pools in a DRS cluster, they are deleted, which means all the permissions, all the sizing, all the everything that I've set for my resource pools are gone. So with Web Client, I can save the resource pool, delete DRS because I'm trying to troubleshoot. When I fix my problem, I can re-enable DRS, re-import the resource pools, and everything just goes back the way it was.